Hello, everyone, and welcome to our latest Real People Big Astronomy event. My name is Renee Kerrigan. I'm a member of the Big Astronomy Leadership Team, and I'm honored and pleased to have with us today Dr. Luis Chavarria, who is the Director of Astronomy for the Chilean government's Ministry of Science. So we are excited to hear about his path to his STEM career and a little bit about his job. Before we get started, I'd just like to mention that if you're joining us on the Zoom webinar, there is interpretation available. So click on the icon at the bottom of your Zoom window to choose whether you'd like to hear this program in English or Spanish. If you're joining us on Facebook, you'll be hearing it in English, and you can click on the Zoom webinar link in the Facebook description, which will allow you to hear Spanish interpretation if that is the language you would like to hear the program in. I'd also like to mention to our attendees that we will be answering your questions at the end of the program. So make sure to send your questions to both panelists and participants so that everyone can see your questions if you're in the Zoom webinar. And on Facebook, just leave us a comment and we will be sure to try to answer as many questions as we can at the end of the program today. The Big Astronomy Program is a National Science Foundation funded project that is all about the big telescopes in Chile and the big science that happens at those telescopes. But more importantly, it's about the people, because telescopes don't make fantastic discoveries, people do. So you can find out more information about the project at bigastronomy.org. A part of this project are these ongoing live social media programs, this Real People Big Astronomy series. And we have the next program coming up is on November 23rd, and it will be featuring Alicia Shugart, who is a science observations specialist at Gemini South. So we're excited for that program. Look for information about that on our social media pages and on our website soon. And with that, I'd love to turn the program over to a conversation with Dr. Luis Chavarria. Thank you so much for being here today. We're excited to talk with you about how you became the STEM professional that you are today.
Oh, thank you, Renee. Hi to everybody. I'm very happy to be here and to talk a little bit about, all the crazy things that I have to be, I did in order to get where I'm here right now. Can I share my screen now? All right. I'm going to share my screen. Renee, you can let me know if everything is going fine or if there is any problem. I guess everybody. All right. Thumbs up. Okay. Well, it is hard to summarize all the things that we've been doing in the last, 15 years, but I'll give it a try. You probably already guessed because of my accent. I'm from Chile. For the ones that don't know, Chile is a country in South America. In fact, it's a very long country. If we compare it to the US, Chile will go from one coast to the other coast. However, Chile is located, in a direction that is north-south, which is pretty cool because there are many, many different climates along our country. And that's because we have the north of Chile. The north of Chile is a very desertic area, super dry. Then kind of in the middle of the country, there are places that are more, with a more humid climate. So it's perfect to growing things. And in the south, the very south, is very cold. There is a lot of snow and water supplies also in glaciares. So what happens with Chile is that along the country, more than 4,000 kilometers of country, there are very special places that are geographically hard to find in other places or other countries in the world. And we call them natural laboratories. For example, one of those is the clear skies in the north of Chile. reason for what we have astronomy located in those places. But astronomy is not the only, or the clear skies are not the only natural lab that we have in our country. We have many more. If you want to learn about beauties of the country, you can go and visit that website. Other thing, December 14th, we are going to have a total solar eclipse. It's going to be total in the south of Chile. And I just learned in the news that I think that Chile is going to open in a couple of weeks. So some of you, hopefully, when we get lucky enough to come and see the eclipse, if you want to learn a little bit more about that, you can just visit that website. The information is also in English. So let's talk a little bit about myself. So that's kind of the oldest photo that I could find of a family from my family. That's my grandfather from my mother's side. And that's a very old photo. He was, very man of discipline. You can see that in his face, kind of very serious. And of course, you cannot read what it says there, but it says Agustín Garrido Mejía, that's his name. And he hand wrote that to my grandmother. And it says to my idolatrada, means that she's like an idol for him. And future wife, Guillermina Gomez Rojo, the name of my grandmother. So that photo is from 1923. Okay, so it's before they got married. I'm going to skip 50 years. I'm going to move to that another photo, still black and white photo. Well, you can see a very happy young couple getting married. Those are my parents. Yeah, I really like my parents.
It's a beautiful, beautiful picture.
Yeah, look at I like the styles, the super small ties. And well, you can see that my grandfather is still there, still very serious man. So those are my parents, and I'm going to move 50 years in the future. And those are my parents now, well, a couple of years ago. They're pretty happy. We're always surrounded by food and drinks because we really like to eat and drink and have very long conversation on the table where lunch becomes dinner. We stay in the dinner table forever, hours and hours. My father is a retired policeman, and my mother worked in a store selling clothing. And they were really intelligent because they used their savings for my sister and my education. So they were very intelligent because the education system that we have in Chile, you're gonna have to have some money to ensure a good education for your children. Well, that's my sister. I didn't have a recent photo of the four of us. But I'm going to show you something interesting in that photo. It's not my belly, it's a little above my belly, but that is a toad. And for the ones of you that have lived or have visited Cambridge, that's a pretty cool bar in Cambridge. And in that place, I took my wife for our first dating. And at that time, my English was terrible. So it was very good that the music was loud, so she couldn't hear me. I couldn't hear her also, but well, I just smiled and said yes. And that's how we got married. Well, let me tell you a little bit about how I was moving around the world in a few countries. And this is all because of the career that I've chose, that is astronomy. So I started as a graduate student in Universidad de Chile, the best university in the country. Now, there are many very good universities. And I moved to Boston as a pre-doctoral fellow at the Harvard Smithsonian Center for Astrophysics. I was very lucky to get that fellowship, and I spent wonderful 4.5 years over there in Boston, where I learned English. But I also studied a lot, and I met a lady, and we fell in love. And well, that's life. So this is to show you how that was not the purpose of my visit to Boston. The last thing that I was thinking is about falling in love, finding my partner there. But that's how life is full of surprises. So we moved back to Chile. We got married, And this combination between Chilean astronomer and somebody from the US is more common than what you think. It's a great demonstration of love between two countries. If you don't believe me, there is my friend Jose from Chile and his wife Jamie from Texas. After finishing my thesis defense in Chile, I had to apply for jobs. And the cool thing about astronomy is that you can apply for jobs pretty much everywhere in the world. So I applied for jobs in many places, and I got accepted in a few of those. And we decided to move to France, to Bordeaux. So I spent 2.5 years in the laboratory of the University of Bordeaux. And that was a great job experience. I've learned so much. I learned a little bit of French. My wife learned more French than me because people was communicating in English at the office. But it was a great experience for me to be there and to know people, to know other cultures. We learned so much living in France. So I'm very thankful for all the people in the laboratory that helped us a lot. I really love my boss. My boss had to take a week off when I arrived there to help me doing all the paperwork, which is a lot of paperwork. So he had to take a week off, and I'm really thankful for that. After our time in France, we moved to Spain, a little bit to the south, getting a little bit better weather. And I was at the Consejo Superior de Investigaciones Científicas in Madrid, and I spent there a little bit more than 1.5 years. So that was approximately in 2010. I don't know if you remember, but at that time there was a huge economical crisis in Spain that affected, of course, a lot of people in Spain, and people that is not from Spain too, because my scholarship was cut. So at some point they told me, we really like your job, but we don't have more money. So you'll have to leave. And then we moved back to Chile. We left Spain kind of in a rush because if you're looking for jobs, jobs begin maybe 6 months after you applied and you were accepted. So, it takes like a full year to get accepted into a job. So we had to move without a job. But fortunately, I found an option to work at what was called at that time CONICIT, and today is called the National Agency for Research and Development. And I was doing a postdoc there where I was spending probably 1/4 of my time, 1/3 of my time at the agency, and the rest of my time I was in Universidad de Chile doing research. And I really liked that job. I had the opportunity to learn a little bit about public service, and I started getting more and more involved with all this administrative work that the team was doing and is doing right now. And I got so involved that I really liked it. And I started a career there. And that was something that it was not my plan, when I was just started studying astronomy. But one thing that it was part of my plan was that at some point I wanted to go back to Chile and to do something for my country, whatever it was. That was part of my idea, and I am really happy that I've been able to do that. Right now, I do not do that through research, but I do it as a public servant, and I'm really happy to have the opportunity to work in the agency. And right now, I'm the director of the Astronomy Program at the agency, so I work 100% of my time doing public administration, and it is fascinating, all the things that we're doing over there. I would like to say that one of the most difficult things that happened to me in my career was the moment when I had to make the decision of leaving research and science. So moving from observatories to a desk job, which sounds kind of boring, but it is not at all. But at that point, I had to make a decision because when you're doing research, the environment in research is very competitive. You had to be publishing papers constantly. Um, and if I was going to be working in the public administration, that meant that I was probably not going to have the time to continue publishing scientific papers, which was going to put me on a disadvantage against other competitors for faculty positions, something like that. So basically, when I decided to change, I was deciding wanted to do this probably forever, because right now, 5 years later, it's probably going to be hard to go back to doing research unless there are some other opportunities where the job is involved in some kind of administration in science. Okay, there's always new opportunities, or we can make our own opportunities. I mean that we can make our own changes. We can make up our own job. So that's one of the most difficult things that I had to do during my career. So far, I guess that I still have many more years of career, and probably things that are going to be harder than that. Um, all of that uh, was not going to be possible without a team. Okay, and I really want to spend a couple of minutes saying thanks to my team, because they're wonderful. Um, this is the most recent photo that we could take, so this is in pandemic times where everybody home. But without their support, it would have been impossible to learn and to change this path from science to public administration. So I'm really, really grateful for them. And they're a really, really an amazing team. And there are a couple of things that you should notice from this photo, uh, other than pets, the cat and the dog. But you can look there, there is something there. That's a blender. I don't have it anymore. Somebody noticed that and told me you should remove that. But that's a blender. And I have a blender because in Chile, it's always a good time to have a pisco sour.
I've been to
Well,
Chile twice, and I agree. It's always a good time to have a pisco sour.
yeah. So you always have to carry your blender with you. Of course, there is a kind of a fight between Chile and Peru about where is pisco, the drink was first made. But after two of those, nobody cares about who made it because it's delicious. Um, One of the things that I think that are hard, or I like less about the job is, well, you can see time. Oh my God, public administration, everything takes forever, forever, forever. There are so many steps, so many offices, so many signatures, so many stamps, um, so many lawyers. But lawyers try to do the best they can. But wow, that was really shocking, coming from science, when I was managing my own time, writing my own papers and things. But right now, everything depends on so many people, and things take months, years. So that was very hard to get used to. I still do not get used to completely, and I keep it like that. You know, I think that is good.
Luis, can you describe a little bit about your job as the director of astronomy for the Ministry of Science? You've mentioned that that's public administration, but what does that job look like for you over a day or over a month, or what sorts of projects does your team work on? Because maybe some of our viewers are thinking of working at observatories, and your job is different than that.
Of course, that's a really good question. What we do is but the agency give funds, state funds for science. We fund more than 90% of the science that is done in Chile. Okay, and our department manages 4 to 5 funds for astronomy projects. And astronomy projects, I mean, for example, if you're a faculty in a university in Chile and you would like to have funds to hire a postdoc, you can apply, to our office to get those fundings. So we fund maybe 10 postdocs per year. There are also other kind of projects that involve development. Small universities that are just starting or with their astronomy department, they need funding to get some infrastructure, maybe to hire or to pay for the first 2 years of new faculty members that are going to be part of that astronomy department. They can also apply to our funds. And also people that is doing outreach in astronomy and science. We reserve some percentage of the funds for outreach projects because we believe that it's really important that scientists talk about what we do, and astronomy doesn't live just on the top of the mountain. Okay, so that's a very important thing to do. And among the things that I really like about my job is that other than giving funds for science or astronomy projects, we are involved in policies to improve the impact of science for our country. And this is just one example that is about light pollution. I don't know if people that is listening, they know about light pollution. But light pollution is becoming a problem not only for astronomy, and that is because the light that in this case, you can see in the photo that most of the light from those street lights is thrown to the sky, okay, and it's not being used for the places where we need light, and that is also some money that's being thrown to the sky. And what happens that that light illuminate the sky, and it decreases the contrast of the skies and the stars. So it's way harder to observe the universe. But also it affects us. The blue component of the light that we see as white light, with these new LED super bright lights, or the screen from our computer or from our mobile phone, that can have a very bad effect in the creation of melatonin, which is a hormone that we produce every day that help us to achieve that super deep sleep. So for example, if we get up at night and we turn on for 15 minutes or 5 minutes a super bright white light, we are going to cut the production of melatonin. And even though we are going to sleep during that night, we're not going to achieve the super deep sleep. And that with time is going to create a lot of physical problems. But also light pollution is becoming a really nasty problem for animals. So that's just to show you a little example. That's a mining worker in the north of Chile, and there you can see golondrinas negra. That's a kind of bird that lives only in the ocean. We never see those birds in the continental land, but because of the light that these companies have during the night, these birds get confused and they go to the light and they get tired and they cannot fish for food, and finally many of them die. So light pollution is a problem for everybody, and we are working in a new regulation for light pollution. So we are really working, creating a new norm for light pollution and to protect the places close to the observatories. So that I really like that part of my job, because I feel like I'm contributing for something that will have a real effect, of course, for science, but also for people. Yeah. Another thing that I really like about my job is that I had the chance an opportunity to be able to communicate science. And we've been involved in many different kinds of projects. You can see there on your top left, Sonia. She's showing an Earth Moon system to scale by using things that you can find in the fruit and vegetable market. We were doing some other videos with kids, asking kids, answering their questions about astronomy. We were doing some crazy stuff like going to a foundation I don't know if that is a real word, but they're melting metal to explain how the atoms are created in the search of stars. And we also participated creating a TV show for kids about astronomy, and putting a lot of effort into showing how girls can be involved in science, thinking about this huge inequality that we have right now in gender inequality for careers that are involved in STEAM careers. Okay, um, we've been doing these outreach events, Dia de la Astronomía, the Astronomy Day, and the Summit for Astronomy Outreach and Education since 2015. Uh, and we've been doing this with a lot of other people from a lot of other institutions, including many universities and pretty much every observatory that is in Chile. So it's around 30 institutions that have been helping us to do all of this. And we're very happy that this is growing. Right now, there is a recent astronomy inclusive group. And they're very eager to create new ways of teaching or showing astronomy to people with disabilities. And we're really happy because all of this is growing. It is based on the effort that we and others were doing 5 to 7 years ago. So this is not going to stop. It's just going to grow. Really happy about that. Um, really happy that now the Summit for Astronomy Outreach is becoming now a summit for science education and outreach. So we're growing. We're trying uh, to see how can we improve the tools that science communicators have in order to teach science, any professional in science. So I really like this part of the job too. Um, well, this is just a video, no audio, but that it shows a little bit what we've been doing in these last 5 years, trying to increase the awareness of the importance of science for people, but also the using astronomy as an entrance door for critical thinking. So that's something that is very important. We need to learn to think. I'm still learning how to think right. Um, but we need people through astronomy, which is very catchy, um, get involved in science and criticize things. Somebody appears on TV and tells you something, flat earth, vaccines, all kind of things. We should give it a second thought about that. And this is what we want to create through astronomy. That's how we are actually using astronomy. So we've been doing a lot of things um, involving other disciplines. You can see there art, music. How can we involve music and art in science, and we can come up with something that that makes sense together. All right, I put that so I can remember that we're going to have some fun too. So Renee, if you allow me, I'm going to do some little experiment here.
Yes, I'm looking forward to it. I'm going to stop our screen share, I think.
Okay, I can.
There we go.
There we go. I'm going to go. I'm going to move this camera. Put it right here. All right. I'm going to move this chair. So what I'm going to do, I like music also, as you can see. I'm going to use this instrument to uh, explain about the cosmic background emission, or cosmic microwave background emission. Okay, it has different names. So can you hear that?
Yes.
Okay. So this is electrical upright bass guitar. And what I'm going to do is I'm going to show you how this works. Well, you probably know how this works. I'm just pulling a string here. And what happens here is that when I pull the string moves and vibrates freely, okay? And it vibrates a certain amount of time per second, which is called the frequency. And When it vibrates, it moves the air, and the air moves, and it makes my ear vibrate, and my ear interpret that as a sound. And this is a sound of a very defined frequency. But what happens if you press the string, let's say in the middle? You can see that the tone changed from something deep or low in tone to something with a higher tone. And that happened because the string became shorter when I pressed it. So if I may, the shorter I make the string, the higher the tone and the higher the frequency. So we'll say, well, what it has to do with cosmic background emission? Well, here's the thing. We can think that this is very similar to what happened with light and photons. Because photons, you can imagine that those are particles that are vibrating at a certain frequency. But different from this bass guitar, the frequency in the photons are interpreted by our eyes as different colors. And the lower the frequency, or the lower the tone in this analogy, the photon will look more and more red. And the higher the frequency, the photon will look more blue. So at the beginning of the universe, when the universe was very small and super dense and super hot, mass and light were kind of the same particles. There was not much of a difference between those. When the universe started expanding, at some point, light separated from mass. And that is what we call the first light of the universe. It happened roughly when the universe was like 300,000 years old. The universe is now 15,000 million years old. Okay, so the universe was very young. So all of these, the first light and an universe that is expanding, all that is a theory, and we need to prove it, and that theory leads to the Big Bang theory. So what happened is that we should be able to detect that first light right now. And if we are able to detect it, that meant that the universe is really expanding and the Big Bang really happened. What happens when a photon that has a lot of energy in a super hot and dense universe is emitted, and then the universe expands? In this case, I'm making the universe, the length of the string, longer, bigger, like when the universe is expanding. But you can see that, you can hear that the frequency is changing. The tone is becoming lower and lower. And if we translate that to light, that will mean that the light of those photons will become more red and more red and more red. I'm going to go back to the presentation. Because the cool thing about all that, it is that if we're able to detect that super red light right now, that means that the Big Bang happened.
That's the first time I've ever seen anyone explain the Big Bang and the cosmic microwave radiation background using a bass guitar. I approve.
Good. I'm glad you like it. So we still need to show the last part. I'm going to share my screen again. All right. Can you see it? All right. So this image shows you, again, a photon and the wavelength, and how the wavelength changes depending on the frequency. In parentheses, you can see that the light that we can see is a very small portion of all the photons that are in the universe. Okay, and one cool thing about this is that if we want to observe photons of different energy, which is the same as frequency, we need to use different instruments. For super high energy gamma rays, we need to use telescopes like those. That's a Cherenkov telescope array. It's going to be the biggest gamma ray telescope. It's going to be built most of it in Chile. For X-rays, well, we do not have much option. We need to get out of the atmosphere. So that's just to show you Chandra, a very nice satellite. I don't think that it's working right now, but it gives super cool results about X-ray in the universe. We go back to Earth, the visible light. That's the Giant Magellan Telescope, going to be one of the biggest optical telescopes, and it's being built, guess where? In Chile.
Chile.
That's the VLT. That's a telescope that to observe visible and infrared light is, again, the biggest of its type, and it is located in
Chile.
Yeah. Too bad I cannot hear everybody responding. If we move to longer wavelength, then there is ALMA, which is the biggest observatory in the world, and is located in the north of
Chile.
All right. Now we go to longer wavelengths. We don't have a telescope here, but we do have places to build those telescopes. Okay. And one of those places in the north of Chile is already being studied to build radio telescopes there. And there is an instrument called MIST there. You want to know more about that, or if you're interested, you can go to that website. But I'm going to go back to what I was saying. So this cosmic microwave background emission, it should be super red light, okay? Even more red than what our eyes can see. So it is located around that area in this in the spectrum of light. And in 1965, two engineers, Mr. Wilson and Mr. Penzias, were building an antenna, telecommunication antenna, and they had noise that they couldn't find out where it was coming at. They were turning on the antenna, it was a shh. What is this thing? They were cleaning the antenna because there were some birds nesting inside, but no, it was not the birds. And suddenly, looking information about what could this be, they found that there were some astronomers in Cambridge that wrote a paper explaining this and explaining that if the Big Bang theory and expansion of the universe is true, then we should be able to see this microwave emission. And they discovered that, and they won the Nobel Prize for that. This is an image taken by WMAP. This is the cosmic microwave background emission. And we can see it coming from everywhere. There are little differences in color there. I'm not going to go much in detail, but those are explained by a smaller difference in the density of the super early universe, and that probably gave birth to galaxies. Okay. Well, I think that everybody has to learn something with this kind of talks. So I hope you liked it. I want to show something else. At some point, somebody asked me what is one of my favorite astronomical objects, and this is one of them. You cannot see it very well because this is in the southern hemisphere, and in the southern cross. So you can see on your right side there are 4 stars that look like a cross, and on the left side there are 2 very bright stars. Those are Alpha and Beta Centauro. Alpha Centauro is a triple system, 3 stars. There are so far that we see only one here, but the 3 of them are very together. But one of those 3 is Proxima Centauri, the closest star to the sun. So sometime in the future, I hope we'll be able to visit that system. But why I like this constellation is because for many cultures, or for one culture in particular, in the south of Chile and the south of Argentina also, they also have their constellations. And this is called the pata de avestruz. So it's the feet of that animal. The animal is called ñandú, and that's the feet of the ñandú. So it resembles the cross, okay? And the other 2 bright stars represent the boleadora. And boleadora was that instrument that was used to catch the ñandú, the bird, because they were eating those birds. So the story here is that one time, the people tried to catch the bird, but they missed. So this is written in the sky right now, so people understand that sometimes we fail. That's why I really like that constellation. Well, I don't really have any questions, but I have like two more slides. But
I think we wanted to know, besides your job, Luis, what you like to do for fun.
you can see, well, you heard me playing bass, but I do play in a band. The band is called Ajiaco. Ajiaco is the name of a meal in different places, countries in South America. Um, Specifically in Chile, is a meal that you do with leftovers in the barbecue. The next day is a soup. So it's very reconforting after a night of party. And we have that name because we play different kinds of music. We mixed everything together: rock, Latin rhythms, a little bit of jazz, and that's the band with our lead singer there. So unfortunately, we don't see each other much right now because we are everybody at home. But you can see some videos that we have recorded by ourselves. Try to keep going with the band. Okay, with this, I'm going to finish. Maybe we will have some time for questions. But just to wrap up a little bit, um, Chile is a very special place with even more special geographical places that we call natural labs. One of those is the skies in the north of Chile. Through these natural labs, we can attract science, big infrastructure for science to be built in our country. Those telescopes are not working right now. Those are being built in Chile, okay? So just for you to have an idea that the biggest telescopes in the world are being built in Chile over and over. And the next generation probably is going to be come to Chile. Through that infrastructure, we have a growing scientific community, but also we can have some spillovers in terms of observatory management, in terms of building instruments for those telescopes. We can move the experience of building instruments to other things. Like there, I'm showing a satellite. That's the first micro satellite, Chilean satellite, everything made at home. And there, with the big data that we are going to need to manage for projects like the Vera Rubin, which is going to generate 20 terabytes of data per night that had to be analyzed. We're going to have infrastructure that could be applied in the private companies, mining, climate change, intelligent agriculture, intelligent cities, many things. So through astronomy, we can have benefits for other disciplines, and we can have benefits for the society. And what we are doing now is we are trying to get this astronomical model, and how can we apply that model for other places that are geographically very important or unique worldwide, what we call natural labs. In such a way, we could use this science, for benefits for everybody. Astronomy for everyone. All right.
Thank you so much, Luis, for sharing about your job and about how you became involved in your STEM career. You have a very interesting and important role in astronomy, especially astronomy in Chile, says you are directing those funds and working on astronomy outreach. A lot of these programs probably feature staff who work at some of the many observatories in Chile, so it's great to hear from the administration side about that role in astronomy. We do have a few questions. One from a amateur astronomer, I'm sure, who says, you referred to the southern skies. How does the quality of the sky in Chile compared with the one in Sutherland, South Africa?
They're very comparable. The one thing that you have to do if you're going to build a telescope or institution is not only the amount of time that the sky is clear, what percentage of nights per year are clear. Also, you have to take into account the quality of the atmosphere, how turbulent is the atmosphere or not, but also things like temperature, how dry has to be for the type of telescopes. As we saw, there are different types of telescopes for different type of science, and those need different requirements. So in South Africa, they're building part of a big project in radio astronomy because there are many, many empty spaces that do not have, mobile phone antennas, so they don't get all the noise from those frequencies. And they're building a big, big radio telescope there together with Australia. So the skies are similar, but it's not the only thing that you have to take into account when you're going to build a telescope. So there are many places in the world that will have advantages or disadvantages depending on the telescope that you want to build. Of course, we have something very important that is the logistics. And there are observatories, the roads are already built there, the infrastructure is there, and human capacity, technically, is also here. So that attracts to have more and more telescopes here.
Yes, Chile is going to have, is it 70% of the world's astronomy infrastructure in a few years?
It is, but it depends on how you calculate that, but it is more than half of the worldwide optical and infrared, telescope power is going to be in Chile.
It's amazing.
Yeah, in a small country. Yeah.
We have another question from Scott. Thank you so much for this glimpse into your life, Luis, and how science is developing and present in Chile. Could you share how science outreach into schools is being encouraged by your agency, and in particular astronomy outreach, and are Chilean students being inspired?
Oh, yes, students are inspired. There are a couple of schools for astronomy every year, and kids can participate in that. There's a competition also every year, and students from the whole country participate in that. And what we discovered that astronomy is pretty much every day in the news in Chile. Every day or every couple of days, there's some discovery, and it was done using a telescope in Chile, or it was done by a group of scientists in Chile. So naturally, many people got interested about what is going on with astronomy in Chile, and astronomers are using that interest to teach. And there are groups that are multidisciplinary, working together, where you have teachers from schools or high school teachers with scientists and with communicators working together, building projects to improve the way that they're teaching astronomy and science. So I think that we are doing a good job by funding some of those projects, since they asked me about how we do that. But also there is a new office. Well, I didn't mention that, but since 1 year we have a Ministry for Science, Technology, Knowledge, and Innovation in Chile. The first time we have a Ministry for Science, we are part of that ministry, of course. And the ministry has one office that is dedicated to outreach. It is called Ciencia y Ciudadanía. Right? So that office is in charge of reaching people with science, and not only astronomy. Okay? So that's another way that we are trying to encourage that connection between people and science.
There's one more question, and I know that you had shared with me you have a meeting in 10 minutes time. So we'll have one more question and then wrap up. There's a question from a viewer on Facebook. Can you discuss a little about the work that you do with other countries around the world as a part of your job?
That's a very interesting and good question, because we do communicate with other countries, especially in the US, because you have many telescopes in Chile, and through also outreach programs. There are a couple of programs that are together, or joint programs between Chile and the US about outreach in astronomy. But talking a little bit more about specifically astronomy and my job, we communicate with other countries for different reasons. One is because universities or institutions from other countries want to build telescopes in Chile. So somehow they reach us and they ask us, how can we build a telescope? And then we trigger a process. Other countries are interested in collaboration. They say to our Minister of Foreign Relations, we would like to see ways to collaborate with Chile in astronomy. And then we contact them, and we have some meetings, and we put them in contact with the um, Chilean Astronomical Association, so CHIAS, to build or to foster scientific exchange. So those are the main ways that we are in contact with other countries. And right now, we've been having meetings with other countries in terms of natural laboratories, trying to learn how other countries are managing their natural laboratories, and see how can we do the best with the natural labs that we have at home.
Well, thank you so much for your time today. I know I've really enjoyed the program, and I'm seeing a lot of comments on our Facebook page and here in the Zoom chat about people who are thankful for your informative presentation today, Dr. Chavarria. We did get a request. Is there a way people can follow you on Twitter? Do you have a Twitter handle or social media presence that people can connect with you?
I do not have, I'm sorry, I have not made up my mind yet, because I have so much work to do that if I have social media, it's going to be hard. But well, I've been thinking about that. Maybe at some point I will have, but um, I'm sorry. I'm sorry about that.
Well, thank you again for your time today. And I'd just like to mention for our viewers that this program, Real People Big Astronomy, is a part of the National Science Foundation funded Big Astronomy Project, which also has a research component. So if you would like to contribute to the research, we would appreciate your help. You can let us know what you think about this event by joining our Zoom focus group, which will be in English. And there's a link to that in the Zoom chat and on the Facebook page. If you join that focus group, you'll receive a $5 Amazon gift card. And there's also a link to a survey that you can fill out, and that's also very useful to us. And if you fill out the survey, you'll be entered into a drawing for a $10 Amazon gift card. So if you're able to help out with our research, we'd appreciate that. And again, you can find out more about this program and about upcoming social media events and the other aspects of the Big Astronomy Project by visiting bigastronomy.org and by following Big Astronomy on Instagram, Twitter, or Facebook. So with that, I'd like to say thank you one more time to our attendees and to Dr. Chavarria, and we'll see you on November 23rd for the next Real People Big Astronomy event.
Take care, everyone, at home.